Okay, is that all there? Great. All right, so I think this was sort of a venue that was asked just to share cool things that we've done at work and things like that. So that's basically what I'm doing today. Hopefully you'll find something useful buried in here somewhere. So I'm Danny Jones. I work at Buybox as a solution architect, and I want to make sure that I add this disclaimer that all the ideas presented in this presentation are a team effort from the people at Buybox all working together. It wasn't me just handing down plans or whatever. We all work together for this sort of stuff. So what we do at Buybox generally is we provide a network of electronic lockers that are opened via Bluetooth apps that we write, and they allow engineers to deliver, collect packages, as I said, via a mobile app on web apps and various APIs, so they can do repairs and fix their engineering problems, fix boilers and hard drives and data centers and things like that. And part of the work that we do is we model those packages, where they are, who added them to lockers, who removed them, who they actually were, when they did it, why and how. But we had a couple of problems at the beginning of the year. And two of them were one of the databases that we used started being the cause of multiple outages. Nothing massively, harrowing, but outages all the same. We using some of our metrics, we found that it was also the cause of quite a few performance issues. Almost everything performance related was involved in that database. We were on an old version of it that was difficult to upgrade. You lots of breaking changes and things like that. I'm not going to name the database, by the way, I don't want to get into arguments. And it was, for us at least, it was a fairly bad developer experience. It was very opinionated and easy to fall into traps, really, without knowing about it until it's deployed and live and millions of people using it and so on. And the second problem we had, which is probably a problem everyone faces, is technical debt. We were still using the .NET framework. Most of our stuff was hosted on shared on-premise infrastructure. So if another team working on a different project happened to have a bad release that used all the CPU, then we could have been affected. Didn't really happen that bad, but there's always that threat looming. And we were using features that didn't really scale well to the sort of demand, because we were pushing this out globally, and we wanted to be able to scale it as needed. So we're using things like MSMQ and DTC and things like that didn't really scale well and weren't really in use anymore. Lots of better alternatives that did. And there's lots of ways you could solve those problems individually, but we wanted to try and come up with a solution that tried to fix as many of them as possible in one step. So we came up with some goals, and we decided that the things we wanted to do was we wanted to migrate the data out of that database. And we wanted to use cloud-first technologies where possible, but we also wanted to maintain regular releases and keep minimal downtime. So that sort of ruled out things like big rewrites and things like that. We wanted to obviously keep pushing things into master. We didn't want to have big long-running branches and things like that. So we had to decide where to start. My mouse is in the way. We had to decide where to start. So what we did was we identified a feature that we determined to be very valuable, that had lots of data in that database, with a well-defined domain that we could try and extract into its own deployable artifact. And we came up with the activities, which is a sort of an audit trail, like a customer-facing audit trail that customers can look at and determine what happened in their lockers that they're paying for. They can see who had opened the doors, what things were removed, what was added, and so on and when. And there's it's actually probably 5 million plus activities in our database. And it's very important to our customers. They're always checking this data to see who's doing what needs to be done next, and so on. So it was a very key piece of work that we've got there. So what we did was, how it existed initially was we've got this very sort of basic. This is cut down obviously for simplicity, but we have a UI, and we've got sort of reading activities and writing activities. So when something wanted to be written, something happens. Someone does something in the UI. They press a button, they scan something into a door or whatever. It gets sent to the API, which does some stuff and sends messages onto a queue, which are read by a service, which then saves that activities corresponding to those events to a database. And the read works in a similar way, except the read just bypasses the service. It just goes, oh, I need to read these some activities based on these filters or whatever, and it just directly accesses the databases and returns the results. So that's how it all. This is all on premise at this time. So the first step, which obviously makes quite a lot of sense, is to make sure that what we're doing before we do anything, make any changes, make sure the tests cover what we are going to be messing around with, basically. So make sure all the tests that cover all our scenarios are there working, and then we can refactor the existing code so it all lives as close together, because in reality there isn't just one service, there's multiple services, and they're all doing their own little things. So we made sure to push all the data as close as possible together so that it's easy to sort of scoop out and deploy somewhere else. So then we ensured that all the messages going into that service were relevant for that domain as well. And we know while we're doing all this work, we can make sure that if at any time we've pushed a change that breaks anything, the tests tell us straight away. And we can ship this at any time. We're making improvements. Even if we did nothing else after this point, we've still made a valuable contribution to the code base, made it more readable and easier to change and so on. And then we went away and started writing something brand new, cloud first in Azure, as an app service that we called the activity service. And we wanted to make sure that the stuff that we created in Azure, because we created bits and bobs here and there before, but we wanted to sort of kind of do it right. So we wanted to make sure that all that stuff was tracked and that we could see how why resources were changed from one thing to another, and so on. So we made sure that we used infrastructure as code. We wrote the scripts that created the infrastructure in Azure for us using Terraform. And that's a whole different subject, but it's been really useful for us to make sure that all our environments are exactly the same and no one's messing around with them outside these scripts. So once we've created these scripts that create the infrastructure that we think we needed after multiple iterations and written some code, we've got a very basic hosted app service with some business logic in there that receives messages, same messages that were being received in the other service on premise, and writing those the contents of those messages to the database as activities in the new database. Obviously nothing's using that in production. Nothing's even sending messages to that queue other than our tests. So we can deploy that and make changes as we want with no worries that we're going to break anything in production. But then the next step is obviously to bridge that gap. We want to be getting real messages into these queues in the cloud, and we want to make sure that, and then that means that the new database is being populated with real data. And we were using a service bus for our sort of queuing, and they have a little application called a router. So we deployed an instance of that in our data center and configured it in such a way you can basically tell it to receive, subscribe to messages of this type or these types and forward them onto a different sort of transport. So internally we were using MSMQ, but in the cloud we've got Azure Service Bus, so we could sort of bridge that gap. So we configure the router to receive the messages that we need to send on to the app service, and then we deploy that as well. So then the router starts receiving those messages and sending them on to the app service. And at that point, from that point on, that new database is receiving the same data that's being sent to the the existing service. So these two databases are adding the same data independent to each other. So that's where we are at that point. We've got, from the moment that router is deployed, the activities are being created in both places at the same time, being kept in sync. And there's no dependency between them. They don't know each other exists, so we can both deploy them at the same time. Features can still be added to the existing system, and no one's the wiser, really. And if we find problems with the new database, we don't like the structure, we find that it's not very performant or whatever, we can just delete it and start again because there's no one reading from it. And that is obviously a problem with getting it into production, is that the database isn't being read from, and that's the next step we need to do. So obviously the thing we do is update the app service. We create a equivalent API, the same sort of API in terms of its interface to the API that we've got on premise here. So we just create one up there as well. It's simple as almost, it's not exactly copying code, but it's the same sort of concept, and that reads into that new database over there. But nothing's calling this this API yet. Still, it's just our tests, and we verify that those tests work. That the same sort of tests that we're using down here to verify that our existing API works can be basically called here to see that we get the same responses out. And then we want to get the old data, the stuff that hasn't been sent through, the stuff that existed before we even deployed a router. We want to get that in the new database as well. And we can do that in a sort of separate process, some migration script that just runs ad hoc, migrate this month's data, last month's data, last year's data, and just reads from that old database and writes them into the new database. And we can verify the results of that. So then at that point, we've then got 100% compatible read API in the new activity service. We've got, we've fully migrated the activity data from day 0 onwards, and that data is being kept in sync with any new changes that come in through the APIs. And the on-premise and Azure service are still independent, but the Azure data is still not being read from in production by any users. So the final step is to get that API being read by the UI. And to do that, we introduce an API gateway. We deploy that to Azure, which is why it's green. And initially what we do is we then, once we've got an API gateway there, and I'll explain a bit more about that in a minute, but we then deploy a new version of the UI that instead of posting directly to the on-premise API, it posts exactly the same content, the same requests to the API gateway, and the API gateway is configured to just forward it straight down to the old API. So nothing's really changed, there's just an extra hop in between for now. So an API gateway sits in between the UI and the APIs. It forwards all requests based on its configuration to a second API, like internal API. And we chose an API gateway called Ocelot. It's in the it's mentioned in the eShop on Containers example in the Microsoft documentation around doing this sort of thing. So it seemed to be a good choice, and it's free, and it open source, worked perfectly for what we needed. So you just deploy a new version with new routes, new configuration, and watch it redirect things to various new places. So we wrote a new version of the API gateway with extra configuration, that whenever a request comes in to read activities, it will instead redirect them to the app service. And that's just a deployment of the API gateway on its own. And then from that moment on, all requests from the UI are being read from the new database and not the old database. And they started seeing improvements in sort of read speeds and things like that. But the old database is still being kept up to date. And then eventually, when you're happy with this, that you're happy that we've migrated all the data, we leave this for a decent amount of time to let any issues that do arise come in. But once we're happy, we can literally just delete the old stuff. We don't need it anymore. And we've migrated that data out. And that's the only point of no return in the whole process. At any point prior to that, both databases were in sync, and we could flip back by just reverting a a gateway, for instance, and we'd go back to reading from the tried and tested old database. And now we've got a whole new service that we can sort of work on independently. Don't have to worry about the rest of the system to get it deployed. And it's sort of a well-defined boundary. So that basic idea, that whole thing just went through there, is kind of known as the strangler pattern. And you can repeat that time and time again. We'll just get a different domain. Think of another domain and just do that same over and over again into different services. And that's kind of what we're doing right now, is we're thinking of other domains that we sort of extracting. And the idea is that the on-premise code base just gets smaller and smaller until hopefully it's no longer there. The biggest issue we had at the time was when we flipped that switch to read, was we kind of underestimated the load that it would have on that Azure database. So we had to quickly ramp up the size of the database, the DTUs that we could use. Plenty of things we could have done to, it's just a learning exercise really. It didn't cause any downtime, but we could have, Ocelot allows you to send only a certain percentage of requests to a specific route. So we could have sort of slowly moved up, or maybe only 10%, 20% of requests go there, and you'd see the usage spike and you think, we need to up this before we take it to 100%. Other ways that we could solve it as well. But that was about the biggest issue we had. I just thought it was pretty cool. I thought I'd like to share it. And I think, yeah, that's about it. I guess we'll leave any questions you want to the end of the whole day.